Today I'm working on a +2 mainboard, which is this one. It's from the grey +2, so not from the black model. It doesn't have the 5-volt regulator on it, which is on the heatsink, so I will mount something like that myself for now for testing. And another thing that is a bit of a challenge is getting video output, because this is not a standard +2 video output. It has been modified, I think, but I can't remember why. I think it was because of a cable that this customer was using. On this board, the composite video has been modded to 12 volts, I think, so I won't use this connector to get composite video. So this board has been with me before. It has been here for quite a while already, for the second time. When the board was initially returned to the customer, it did work, but it's I think something like after half an hour it became unstable, unreliable. And now it doesn't boot anymore, does the customer say. So before actually powering it up, I don't think the edge connector is clean. It looks quite dirty. I'm not sure if you can see it. Let's clean up the edge connector. It is a bit corroded because of the age, I guess. But it's not a big deal for now. Let's just clean it. Using this glass fiber brush, which gets off most of the dirt. Be careful with the glass fiber brush, because those are tiny glass hairs and you don't want to get in your fingers. Let's power up with 5 volts only. Sorry, 9 volts of course. And see if the board does anything. And of course it doesn't do anything right now because I don't have a 5-volt regulator on it. So that's the first step. We'll grab a Traco power or something. So let's grab a female pin header block. I think it will fit just fine. Yeah, that's perfect. Just need to cut the part off. So this is ground. Yes. This is input. It doesn't do anything. Okay, this is input. And this is 5-volt output, and we can check that as well because we can measure the 5-volt input of one of the logic chips. We'll get this off. We'll move the board around because I need my right hand for the soldering iron. That's 1, that's 2, and 3. Okay, those contacts are fine. Looks great. Let's see what the board actually does. It is doing something, but it's really almost nothing. You can see there's no +12 volts, so I think there's something wrong in the power circuit. To make sure it's not one of the parts that are socketed already, let's get them out, because maybe one of those parts is making the board not boot up. Still no 12 volts. We do have -5 volts, only not the 12 volts, so most probably just one of the parts in the voltage circuit is dead. And we have to find out which one that is. Right, so this is the schematic of the power circuit of this board. Let's grab the multimeter again and let's try to find the culprit and see if we can fix this. So we don't have 12 volts. Now you can see that the 12 volts is coming from R55 1K8 resistor. So we can check that. And there's a diode which is D19, which is in series to 12 volts. So those two are the first that we can check. Then of course we have the TR9. Let me show you. There's this transistor here. That could be the problem. This one is D19. Let's get it out on one side. This will be a bit hard. Yes, it's out. Let's put it in diode mode. We get a reading. So it's 0.5, which is okay. Let's get back to the schematic, and the next part is the 1K8 resistor, which is R55. Don't see. Oh, here it is. Okay, it's out. Let's measure it. Yes, it should be 1.8K, and it is. So that's no problem at all. Let's take a new one. Why not? So, what I wanted to tell you about is this. So I thought I had to check D19, but it's actually D20 I have to check. This one here. So I was checking that one, and I should have been checking this one here, which goes to the 12-volt line. So I expect 0.5 as well. 0.5 voltage drop. Yes, exactly. Measure the other way. It should be nothing. Let's see. Okay. Nothing wrong here. Do a quick test and see if anything has changed. Just want to know if there's 12 volts, right? I don't think so, but it's good to check in the meantime. Okay, still no 12 volts. Okay, so I still think this must be it then. This is a 753 instead of the 213, and this is a 653. So let's replace those. All right. Okay, let's replace that BC213. We have a 753 now, which is a perfect replacement for that. Let's do another test. Do we have 12 volts now? Why not? Yes, we do have 12 volts now. Okay, let's see if that makes any difference with booting up. It's still doing the same, there's not much. So we have all kinds of data lines doing nothing, only data line 3 and 7. What could that be? What I see is a lot of corrosion on those pins. Let me show you. Can you see how corroded those pins are? Yeah, you can see it easily. These are rusty, can you see that? Really rusty pins. So I will get the chip out and we will see if that has anything to do with the board not booting up, which wouldn't surprise me. And that will take some time because it's corroded, but we'll see. There's so much rust. Let me see if I can. Man, let me show you. So I can see loads of corrosion here. It's not bad everywhere, but okay, I can scrape it off easily. So that's good. That's good. But I need to use a magnifier to see if there aren't pads damaged. This one looks especially dirty. So let's see. Now that VIA is okay. Let's give it a good clean with some IPA. The chip looks really bad. There are fortunately replacements for that, so that's not a big deal. That's a lot better. What I could do is test the crusty one on this board here. And let's see first if we get anything on the die card. Yes, okay. Let's just see if we can add it now. Yeah, I can even put it on mono, so we have it on both sides. Alright, so this is working. That's the only thing I wanted to know. And now I want to put in that crusty chip. Nope. Let's get it out. And maybe, can it be saved in some way? I don't think so, there's so much rust. We don't have video output, that's no problem. We just want to see if the die card is doing anything. Nothing. It's a bit more. You can see there are more LEDs flashing now, 4 at least. So I still suspect there's something wrong with maybe the RAM chips. I have no clue. But it's definitely not booting. We can see that because if we change the switch here, it should count down the LEDs, but it's not. I didn't replace this LED in this board, did I? So maybe that could be it? Don't know for sure. Oh, you cannot see what I'm doing here, but now you can see. Alright, so let's get this one out. Okay, still the same 4 LEDs that are blinking. Nothing more than that. What I will do is test this ULA chip on the other board, not the other way around, otherwise we could damage the good working ULA chip. Let's see if this ULA chip is working correctly. Okay, the ULA chip is fine. Let's see if the other LED is working as well. Okay, this LED is fine as well. Let's get back to the customer's board. You might think, shouldn't there be a ROM in there? No, for a die card you don't need a ROM actually. So, let's see, do we get anything else? Otherwise we really need to, oh wow. We do get something else, but now it's completely... It's really odd now. Oh, look at that. Did you see it? Did you see it? Look at those 2 LEDs here. Oh, yes. Now the camera's not perfect, but these two LEDs here are now stable, and if I push this in, you can see they start blinking. So, oh my god, I hate this. I have no clue. Oh my god, it's just the module itself. There's still, you can still see that when I push the chip here, deadline 0 starts. Oh wow, oh wow, oh wow, this chip is incredibly hot. Yeah, it's becoming hot again. The Z80 is only using 5 volts. Why is it becoming hot? I have no clue. What could it be? So in here it's 25 degrees. This chip is already 35. It's increasing rapidly. It's 40 degrees already. This is not normal. 47 degrees, what the? How can a CPU get hot that quickly? So the only reason I can imagine that a Z80 is becoming warm or hot is that it has shorts on the data lines or address lines or something. So I really have my doubts about the memory chips here. Still, we saw the issues with pushing on a board. The only thing I can imagine is load on the address or data lines, some low resistance load that could be caused by the RAM chips. Even the sound chip could be causing this. Yeah, here it is. So that also connects to the address bus and the data bus. So that could be a cause. I think it's wise to get it out as well. Maybe I will start with that. Okay, so let me get some chips out and see if that makes any difference on the temperature of the Z80, because we have to find this. I quickly had some success. I removed the white chip and I thought, well, let's measure the temperature of the Z80 again. And I connected the die card and look at the result. We don't have video yet, so don't have to show that. It's counting down, so it's working. The machine is working. Still, the Z80 I think is still getting really warm. I don't think that is normal, but I have the feeling that there are several things wrong with this board. So there's still some load on the pins on the Z80. The chip is getting warm. It's still working, so that's good. What I could do is measure the resistance on the address and data lines of the Z80 CPU. So I need to find a good ground spot, and let's do that. Pin 6. All right. So pin 6 is ground. Now we can just go to resistance mode, and we can start measuring. So the first one, A0, is pin 30. I'm going to write on the Z80 chip pin 1, pin 20, this is 21, and this is pin 40, pin 30, and pin 10. Alright, so let's start with pin 30, which is this one, and that one measures 5 mega ohms. 31. It's the same. Pin 32. The same. Pin 33. So let's get to the data lines on pin 7, 8, 9, 10, 12, 13, 14 and 15. We're going to test those as well now. Interrupt request signals, memory request, so let's check those. I think it's best to just check all the pins and see if we can find any pin that has a low impedance. I can't find anything else, so it could be one of the chips here. Now we can do two things. We can just get these all off, or we could get a video signal and see what the die card says. Maybe it will point us to the defective chip. So I think the best is now to get the video output. Usually we have that on pin 2 of the RGB connector. We have a composite video signal somewhere. Let's find it. So we have to get back to the schematic again and find where the composite video signal is created. It's there. So we have here the 3 diodes and the transistor, and here you can see that either LK2 or LK4 must be connected. If you connect LK2, you get a 12 volt output on pin 1. I thought it was pin 2, okay, pin 1. And if you connect LK4, you get the composite video output. So at this moment, I will point it on the board. LK2 must be connected, and indeed LK2 is connected. So this is this wire here, this wire, and LK4 here doesn't have a wire, and that contains the composite video signal. So let me check which side of the connection it should be. So this is composite video. I will stop the beeping. So we know where composite video is now, and I will put a RCA connector on that. Let's use white for the composite video signal and use blue for the ground. Okay, so that should be composite video. We should see something on screen. The only problem is that we still have an overheating Z80 CPU, but I want to know if it's being caused by a memory chip. Let's get back to the test view with the video and see if I get something. It's not booting anymore. Why is it not booting? I don't think this module is reliable. That module here. Let's grab that one and see if that module is just unreliable, which I expect. So this module, I'm not sure what it is, but what I want to know is if the ROM is okay, and next if the RAM chips are actually fine. And I still don't know why the CPU got hot. And I also don't know why composite video is bad. Anyway, I do have output, so... Okay, we have RAM errors, so that's good. That's what I expected. Because this is a +2 board, it will show us exactly which chips are failing. So I expect one chip to fail. It's 24. That's easy. Let me check the temperature of the CPU. Why is the temperature okay now? It's not warm or hot or something. Okay, so for one, I know that this module is not reliable. I had a video improvement for +2 here as well. We need to find C31. So it's this capacitor here. When we just lift one leg, it might just solve the incredibly bad video output. Let's see, do we have a proper video output now or not? Yes, we do. Yes, look at that. That's different night and day. So it was just that capacitor, and you can see how much it scrambles up the video output. So now we have proper video output, though the only thing is IC24. Looks like that's the last thing that's wrong with this board now. And I will have to check if the AY chip was working or not. I removed the bad RAM chip, it's here, and I placed in a socket, and with a little luck, that's one of the last things I need to do for this board, except into the AY chip. But of course we are curious about this RAM chip here. Is this all that needs to be done on this board? And that's what we're going to test now. So we're going to see if the machine is booting up. I won't plug in the die card because I'm sure that it will boot now as it should, because this was the last chip that was failing. I think it will boot, and then we will get to the AY chip and see what it does next. I know you're all waiting for to see if this board works, but I want to show my new device that they created. So here's a blue box, as you can see, and in there is a new video converter. I had in there a old one. I still have it somewhere here. So this was the old one. This is a very cheap one. I think it cost something like 20 euros. So it made HDMI from composite video, but it had some kind of interlaced video processing, so the video was bumping all the time, and it didn't pick up many signals from ZX Spectrums very well. So I had all kinds of problems, especially when it comes to the brightness of the video. So I wanted to find a better one, and I found a better one. I posted it on Facebook, and I built in the PCB in the same enclosure as I had the old one in. And this enclosure has, at the left side, it has all the inputs, so 9 volts for the Spectrum, which goes to the output on the right side here. So this cable here, it's a 9 volt output to the Spectrum with this the switch in between. Then we have an RCA output on the left to the small display here. And we have the RCA input here for composite video from Spectrums, and it picks up the signals quite well, as you already noticed on this +2 board, even with the distorted video output because of the audio signal. I also have the audio input, which is stereo, so you can use a stereo input like using a ZX-AY or a ZX Spectrum with a stereo output. And I have a switch here when you have a mono source like 48K ZX Spectrum, or this +2, which has only a mono output here. You can switch it to mono and you get the output on the left and right channels. So at the back you also have the USB output. So in here is the video converter, and then a capture device that converts HDMI at 1080p to USB. And that works fine, although I noticed yesterday that the audio on the capture device is only mono. So what I did is I integrated a second stereo connector at the back, and that goes to my sound card that has an SPDIF connection to my amplifier. And it also has an analog input, so that's useful for recording analog stuff, like, for example, now it's going to connect the ZX Spectrum to. And that has a stereo input, so that worked just fine. And I also have one extra connector at the back, which I added yesterday, because the video converter has a 5 volt input, and I wanted to use a simple Recom or Tracker Power 5 volt switching regulator for that video converter, but when I was using that, the video got all distorted. I don't know why. So I tried several things. I tried using capacitors to flatten out the power source, but that didn't work. So in the end, I added a 5 volt power supply, which came with the video converter, and just plugged in the 5 volt at the back as well. It's not the nicest, but anyway. And I got some holes, and as you can see here, some holes at the bottom and top to make sure that the video converter, which can get a bit warm, it also has a heatsink, actually can have its warmth go out of the enclosure. So that's all. That's what I wanted to show you. So I finally have a good video converter, which I now dare to use when doing repairs like this. Back to the thing you're all waiting for. So we put in a new RAM chip, and now we want to know if this machine is working correctly. Sorry. That was stupid. Okay, let's grab it off again. Hey, it is working. So the board is finally working, except for the UI chip. We'll test it in a second. Man, so we got out this crusty chip that still seems to work on other boards, but doesn't work on this board for some reason. After replacing that, we found out that this module was unreliable, so we grabbed another one which is on the board. I will leave it in. We had problems with the Z80 CPU. It's slightly warm, but it's not heating. And we did get a video output, but it wasn't good, so we lifted one leg of the capacitor that adds audio to the video signal, and now we got a proper video output. The only thing that we can improve is the yellow and blue ghosting, which you can see on the screen. It will improve once we do the modification. Let's get those parts. So these parts, the last thing we did was replace the RAM chip that was failing, and now we got a working board finally. Okay, let's see how warm this chip gets, and it doesn't get warm at all, so that's a good thing. I don't think it's heating up that much. I still think it's a bit warm, but I will keep an eye on it. It might have also been that module, you know, doing all kinds of crazy stuff on the Z80. So what I will do is I will just leave it running for a couple of hours and see if it's stable. I think for now it's okay. Let's just test the AY chip and see if that's still working on another board. And we'll test it with that. Put this in here, we don't need a die card. Let's grab a keyboard. Alright, let's see. Does all of this work? This will still work. Let's do a quick test. Okay, so this one is working fine. Now, what do you think? Is the one that we got from the board working or not? Let's see if it works. Power's up at least, so that's good. Shall we do the same demo again? Yeah, it works. Okay. So I think the chip is also working fine. Oh, it's working. Let me put the volume up a bit. Isn't that incredible? And this is on a normal ZX Spectrum. It's unbelievable that they can make these demos these days. A quick added note, I forgot to switch off the mono switch. So you're actually only hearing 2 of the 3 audio channels. So please keep that in mind and just download this demo, which is called Unspoken Yourself, if you want to get the full experience. Alright, so the AY chip is okay. So I think we tested all we wanted to test. Let's finish this video because, well, it has been long enough. I liked working on this one because it was quite a challenge. We had some strange behaving issues, which we sorted out, and I think this is a good result. I hope you liked the video. If you did, then please like and subscribe, and I will be back with more repair and refurbishment videos. So, bye!